Start my meeting. Okay, I'm going to go ahead and get started and assume some other people will come in a little bit. Okay, today, Wednesday, we are going to be doing some more momentum, impulse momentum, mostly conservation momentum. Momentum's conserved when there's no outside forces acting on something, so there's no friction acting on something. If there's friction or some outside force on it, then there would be an impulse on it, which would change momentum. So we're going to finish whiteboarding worksheet 2, start whiteboarding worksheet 3. Probably won't get through the whole thing. That way you should be ready for your impulse and momentum test. It's not going to be like a 50 point. It's not even going to be, it's not going to be 100 point. I don't even think it's a 50 point. I can't remember how many points it is, maybe 40 something. I can't remember. It closes at midnight, so you'll be able to get started on it after class today. Also, don't forget, you probably want to keep on doing some practice, and we'll talk a little bit more about the AP test on Monday. Okay, so I've already shared with you last week worksheet 2, and we've done most of the problems on here, but we haven't done problem number 4 yet. Problem number 4, I don't think we've done number 4 anyway. Number 4 is we have this cart that's moving across the floor at 2 meters per second. And there's this boy that's riding on it, and he jumps off of the cart and he hits the floor and he's not moving at all, so his speed 0. So what you have to think about is what the event is. You know, that's where you're looking at the before and the after momentum of the system. I'm okay if you don't want to do the diagram up here, the part A, but I would like you to go ahead and do part B, C, and D with your partners. So let me go ahead and stop sharing. That's problem number 4 in worksheet 2 file that I've shared with you already. If you could go ahead, I need to get some of you in groups still. All right, let's see here. All right, let's see. Does everybody have partner? No, Nathan does not have partner. Okay. So let's see. Nathan, I'm probably going to have you in a breakout room with somebody that's not sharing a whiteboard with you, but at least that way you'll be able to talk with them. So let's see. All right, so the rooms are open for you. Sophia, you should have got a invitation to join breakout room 1. There you go. Okay. Okay, I think everybody's back now. I'm going to go ahead and share my desktop with you. So again, this was the problem. We have this kid that's jumping off of a cart. So I always think it's kind of a good idea to kind of sketch a picture so you can at least imagine what's going on. So we have this cart that's moving around. It has this kid on it. So let's say here's the kid. I'm not going to draw a complete stick figure, but anyway, the thing's going like this, and then afterwards, so I'm going to see if I can sketch this again. Afterwards, the kid jumps off, and he's or she's not moving. And so in order to conserve momentum, then this car is going to have to keep on moving in the same direction, and it's probably going to be moving. How about you guys unmute yourself? Will it end up being faster or slower to conserve momentum?
Faster.
Can you unmute yourself? Faster or slower?
Faster.
I can't hear anybody. Oh, I'm sorry. Duh, I'm sorry. My speaker is muted. I'm sorry. Could you do it one more time? So since I'm not technology savvy here, can you help me one more time?
Faster.
Thank you. Thank you. Thank you. I apologize. Good. So it's going to have to be faster. Okay. So I'm just going to pick one group at random and kind of look at what they got here. So oops, I think I'll pick a different group because then it'll be a little bit less confusing to look at it. So for their conservation momentum part B, they said the change in momentum is equal to PF minus PI. And so that should be equal to 0. And so that PF equals PI. Nice. And then let's see here. They figured out the impulse by doing 70 times 0 minus 70 times 2, because that's the change in momentum of the boy, which should be the same as the change in momentum of the cart. So, and it says how large, so you don't have to worry about direction. So if you got a negative, how large, you should probably drop that negative. And then finally, that change in momentum is going to be equal for the car, MVF minus MVI, and got 4.8 meters per second, which is definitely a lot faster. It's like over 50% faster. So any questions on that? No? Okay. So I didn't have time to look at everybody's. Did everybody get that? Kind of give me a thumbs up if you got 4.8 meters per second. Yeah, okay. All right, the next problem then we're going to be looking at number 5. Same thing here. You don't have to fill out part A if you don't want to. It's totally up to you if you want to do that. But in this case, we have two girls that are kind of facing one another on skates, and they're just kind of standing next to one another, and then all of a sudden they kind of push off one another, okay? And so you're supposed to write the conservation momentum equation, and then I'd like you to calculate the impulse that each girl gives the other one, okay? It doesn't ask it. I'm kind of surprised it doesn't ask it here. Let's see, part 6, number 6, does it ask? It does not. Well, you know what I want to do with number 5 is not only do you calculate the impulse, I want you to also go ahead and figure out the speed of the other girl. Okay, it only gives you one of the speeds, so I want you to find the other one too. So this is problem number 5. Let me open up the breakout rooms. Okay, I'm going to assume that since nobody's calling me that you're understanding this stuff, it's pretty easy, I'm hoping. So let me share my screen with you. And I'm just picking one here at random. They wrote their conservation momentum equation. They found the change in momentum just by taking 50 times 10. They got 500 Newton seconds. And I also asked you to calculate the speed of the other girl, which is the 70 kilogram girl. We got 7.14 meters per second. I kind of want to show you a picture that I made here. So this is the before picture, and here's the after picture. What's the event in this case? What would you call this? Would this be, what were they? Elastic collision, inelastic collision, explosion, or perfectly inelastic collision? What would you call this type of event?
Explosion.
Explosion. I want you to look at my picture here because we really haven't talked about this a lot, but if anybody's studying Unit 5, which I hope a few of you are, on your own, there was some problems that was in that file that I shared with you, talking about center mass, which by the way is like super easy, especially if you're good at math, to figure out the center mass. But I labeled the center mass of this. The truth is it's probably not exactly in the middle. It's probably, since the person on the right is a little bit more massive, it's probably right about there. Okay. And I want you to watch that center of mass. Now I have to adjust this one. After they explode away from one another, I want you to look at it. So the center mass, if you look at it very carefully, doesn't really change at all. It's not moving. That's because before the explosion, it wasn't moving. And so after the explosion, it's not moving. When I say center mass, I'm talking about the center mass of the whole system. Now you'll notice that the girl on the left, she definitely moved away from the center of mass. And the girl on the right, she also moved away from the center of mass. She's a little bit further. It's kind of proportionalities if you look at it. The girl on the left is 50 kilograms, the girl on the right 70 kilograms. So the girl on the left is going to move proportionally further away than the girl on the right. It has to do with their masses. But that center mass, it doesn't change. And that's the interesting thing about the center of mass. It's saying that the momentum of the center mass has to stay the same. And if you start looking at center mass, it actually makes things a lot easier. Anyway, any questions? All right, so now the next problem we're going to be looking at, let's see, number 6. Okay, so this one is kind of a William Tell thing. We have, instead of an apple, we have a melon, and there's an arrow that's going to go through the melon, and it comes out the other side, and we know what the speed of the arrow is, both before and after. But we want to know what the speed of the melon is as it comes off the person's head. So let me stop sharing. Again, I don't care if you do part A, but please go ahead and do part B and C. Let me stop sharing and break out. Okay, so again, I'm going to kind of just pick one at random here. So let's see, pick one down here. Okay, so they wrote their conservation momentum equation. PF has to be equal to PI. And so they plugged in all their numbers for the initial momentum. It would just be the arrow moving at 30 meters per second. And afterwards, it's the arrow moving at 18 plus the melon moving at some unknown speed. And they found the velocity of the melon is 0.3 meters per second. And I love the fact that they got the direction on here, and that direction is in the same direction as the arrow. So that's kind of important. Any questions? All right, so then I've also shared with you another folder I just did this morning. Um, Worksheet 3. We're not going to be able to get going on all of it, but I was thinking maybe we could look over. Let's see if there's one that maybe stands out as different. Number one, we have a cannon. This would be like an explosion. I don't know. We could do that one, but it seems easy. Let's see. This one, we have a truck that's rear-ending another car, and it causes the truck to slow down. So here we have a truck that's moving too fast, and we have a car moving in front of it, and it rear ends this car. And what happens is the truck slows from 14 to 12, and we have to figure out the speed of the new car. That's a different one. How about we do number two? So number two in worksheet 3. So again, I don't care if you do part A, but please do part B and C. So we're doing number 2 on worksheet 3. So let me stop sharing and open up the breakout rooms. Okay, so again, I'm just going to kind of share my desktop and pick some group at random. So let's see, seems like I'm always picking over there. How about here at the end? Oops, that was mine. I just was playing around with pictures. Oh, actually, I do want to ask you a question here. So hopefully you can see on the left here would be kind of the before picture, and over here on the right is the after picture. Notice the truck was going pretty fast, and now it's slowed down. My question is, I didn't change the arrow for the car at all. You'll notice I have the same length arrow. If the truck's going to slow down, what do you think is going to happen to the car? Can you unmute yourself? What do you think would happen without even doing any calculations?
Speed up.
Yeah,
Speed up.
speed up.
Yeah.
Okay, good. So it's always kind of good idea to kind of do a common sense thing first, and then do the computation, because you might end up finding out you made a mistake in your computation somewhere, and this would help you a little bit. All right, so this group here went ahead and did that conservation momentum, and they got 21.33 meters per second. And again, it would be in the same direction it was going, I think. So, yep, it did speed up. All right, so let me look at the next. Actually, I don't know that we're going to do any more, because I looked at all these problems and I thought they were pretty simple. I do want to talk about number 3, because it's kind of interesting. We have this this atom that decays. So it's what is this? I think it's radium or something. Yeah, radium, and it decays. So it's just sitting there, it decays, and it turns into radon and an alpha particle. If you ever heard, oh, alpha particles, nothing special about alpha particles, just helium. If you ever had a helium balloon, it's just filled with a bunch of alpha particles. Okay. But can you unmute yourself for a second? Because I want you to tell me, what kind of event is this? Is this like an elastic collision? You know, what is it? What is this?
Explosion.
This is an explosion. So there's nothing really special about it, but if you ever heard of the Large Hadron Collider, like in Switzerland, where they're discovering new particles and stuff, what they use basically is two ideas. They use conservation of momentum, this type of stuff, and they use conservation of energy, which we did already, to kind of figure out some stuff about those particles, like what is their mass, what's their speed, that kind of stuff. They know that momentum has to be conserved and energy has to be conserved. There's one more thing I need to tell you about that is not going to be on the test today, but you might see something like this on Monday's AP test, is dealing with momentum. I'm going to redraw this. Let's say that we had some kind of decay that decayed into like 3 different particles. So this is before, and then the after looks like maybe something like this. And we have something that takes off this way. Oh, by the way, they call these things daughter particles, if you're kind of wondering. Let's say we have another one that kind of shoots out this way, maybe. Can't draw. There we go. Shoots out that way, and then maybe we have one more that kind of shoots maybe down this way somewhere. I don't know. And what you should see about this one that's a little bit different, it's still conservation momentum, but the problem is we got 2 different dimensions. We have an X dimension and we have a Y dimension. So here's the question I have for you, that I'm hoping you can unmute yourself, is that in this previous problem we're looking at, momentum's conserved in the X direction. What can you guess about momentum conservation over here in my picture here, where I have them going in different directions?
Conserved in the Y direction.
Yes, and the X direction, both. So that's the only complication, is that you would have to write 2 equations for this. You'd have to do P initial in the X direction has to be equal to P final in the X direction. That's one equation. And you'd have to do another equation of P initial in the Y direction has to be equal to P final in the Y direction. It's not really that much harder, because in this case, especially in this case, because before the explosion, the initial momentum 0, so it's not that much more difficult. We just didn't have time to get into it. It won't be on your test, your Canvas thing at all. All right, so let me I don't think we're on whiteboard any more of that. Close out all these tabs, sorry. And what I want to talk about is a little bit more about the AP test. So again, this Saturday, you should get your email with your AP ID, although the College Board isn't communicating very well, so perhaps you have it already, I'm not sure. You might want to go ahead and do some more practice so that you know what you're doing. I'm hoping that you picked up your packet at school. By the way, there's still, like 20% of you haven't emailed me, so I don't know if you got the packet or you just forgot to email me. Please do that. I'm hoping that you look at in there. Here's what I want to tell you. I'm the most confused this year than I've ever been about AP, and that's because they're not communicating very well. And so I want you, when you go into that test, I want you to do whatever you feel is comfortable for you. So in other words, if you look at my answers in the packet and you're like, oh, I can't type that out. I'm just not a word person. I'm more into, I can draw stuff like this. I can draw force diagrams. I can write equations. That's something I'm comfortable with. Okay, do that then. Take a picture of it and upload it. And by the way, I've heard, you should experiment with this a little bit. I've heard on the AP website that you can take a picture of it and of course rotate it, but save it as a PDF. What's nice about saving it as a PDF is not only will it have your pictures and stuff on there, but it will also have your words on there. And so they would be able to see both of those things. So I guess my advice to you is do what you feel you're comfortable with. If you're not comfortable with writing out paragraphs, then do stuff like this, whatever you're comfortable with. I would also say this to you. I would say, whatever you make, let's say it's a Word document, or let's say it's this thing, don't throw it away, save it, put it in some file, because afterwards you're going to get your scores, and they're also going to share with the teachers any scores that are below a 3. And I can contest those. That doesn't mean I'm going to win. I don't win much battles with the College Board, but I can contest them. And so if I feel like that's not fair, especially if I've seen your work, I don't know, maybe something would happen of it. I don't know. So I feel bad that I can't give you more advice, but that's about all I can do, I think. Does anybody have any questions for me?
Before
Okay.
you
I'm sorry.
I've got a question.
Yes, Chloe.
Before you would recommended just typing it, so
What's
do
changed?
you still recommend that?
Okay. I'm so frustrated with the College Board. It's almost driving me to tears, because so Chloe, to answer your question, is the only reason I've recommended that is because that was what I read between the lines. They're so cagey, they won't say, yes, just do this. And so every time I was saying, well, can they take a picture and do this? They would just get on me. I mean, I feel like I was attacked, kind of. They would actually say stuff like, why are you telling your kids to do that? Just tell them to type. And so I'm like, okay, I'm going to tell them to type. Well, then recently they're now saying that they might accept pictures like this. And so I asked them, hey, so will you accept like stuff like this? Will you actually give them credit? And they're kind of doing this. They're doing the shoulder shrug. Maybe we will, maybe we won't. And so I really don't know what to tell you. All I can say is just do what you'd feel comfortable with. So I have a feeling that a lot of you don't feel comfortable typing the response. That's why I'm hoping you picked up my packet and I put on their example answer where it was all written out. I'm hoping that you would actually try to solve those problems yourself and go, yeah, I couldn't have wrote that. Or maybe you're like, yeah, I feel pretty comfortable. I'm pretty good at English. I could write that out in words. Well, then if you can write it out words, that's what I still recommend, because I think that's what they're going to give you points for. However, if you're not a wordy kind of person. You can't write out paragraphs like I had. And they weren't big paragraphs, by the way, just a couple sentences. But if you're like, I'm not very good at that, I can't do what Mr. Lenfest did, then I would recommend do what you feel is comfortable. If you're comfortable drawing force diagrams and taking a picture of it, do that. Do that and save it so that I can maybe fight the battle and win it. I don't know. Okay. Thanks for the question, Chloe. Any other questions? Sorry, I'm letting my frustration show a little bit. I shouldn't. I think you guys are going to do well. But I just wish they would communicate a little bit better, and I'm just not getting very good communication from them. So, all right. So, just want to remind you again. There's the link here that you can take. I think it's open right now. It's open till midnight. Oh, actually, I want to go there. There's not a code to get on it. Oh, there. It looks like it's 30. It's actually 36 points because you can get. I think you can get 2 points of bonus. But the truth is, some of them are multiple choice or calculations, and some of them are like essay, like not essay, just a sentence or something, or explaining something. You need to understand that the computer doesn't grade those essay-like things. I grade them, and I'm only grading them once at the very end. So the multiple choice and stuff like that will grade right away, and you'll know what your score is. And you could possibly get the computer score of 22. And if you're getting less than 22, I would say go ahead and take it again. But I'm not going to grade those narrative things until the very end after everybody's done it. So any questions on that? I know that's a little confusing. Okay, I think that's it. I can't think of anything else. Again, if you went in and picked up a packet, please send me an email if you haven't done so already. And if you haven't picked up a packet, please go in and get one. It's in front of the school. All right, that's it. Thanks. Bye.
Thank you. Goodbye.
Bye.
Thank you.
Bye. Wendy, do you have a question for me?
Oh no, I was just
Okay.
checking is there a code or something?
No, there's no code.
Okay, thank
No
you.
code. Yep.